Hello, everybody. Once again, thank you for coming in. My name is I'm a senior geologist with DMT Kabata here in South Africa. And today we're having a presentation from my colleague Karsten Zimmermann from Essen, Germany. Karsten, you can go ahead with the presentation in the meantime while I introduce you. Karsten is the deputy head of geofield and under the Civil and Engineering Division for DMT Group. He's based in Essen. He has been with DMT Group now for over 8 years. Karsten and presentation, and thank you everybody for coming.
Thank you very much. I hope you can hear me clearly. Greetings from Germany. Looking forward to this presentation. Much for the invitation. The topic today is slope monitoring, general approach, and also our special news service, which is called Safeguard Live. And I want to show it to you using a few slides here. Let me just or allow me to introduce DMT for a few minutes, where we are working in the field of civil engineering, infrastructure, natural resources, plant and product safety. We are based here in Germany. We are part of a larger company, a big certification company. We are around 1,000 employees over the world. We have 13 operational engineering and consulting companies, 30 branches worldwide. And we have a strong history in the coal mining industry here in Germany, going back to 1740 something. These are our international locations presence. Based in Germany with our headquarters, we have around the globe offices. And one of this is, of course, in South Africa, here DMT Kai Butler, which is shown on the map. We have also offices in Australia and Canada, South America, and so on. These are our 4 markets, plant engineering, process engineering. So we really track plants, chemical plants, for example, from the early studies, recommendations, EPCM, until the plant is finished. We have the market civil engineering infrastructure. This is mainly civil engineering, so open construction pit, evaluation, geotechnics, monitoring, and the construction itself. Mining, of course, from geological studies, feasibility studies, consulting to big mining companies, how to improve their mining operations. And we have energy. So this is mainly seismics for location of natural resources, oil and gas reservoirs. We operate a huge fleet of these shown Vipro trucks to conduct these services worldwide. Just I want to mention, we have a really interesting campaign on our website, which is called Engineering Performance. You can visit our website. We have certain or several stories from the client perspective on our offering. Really interesting on monitoring, electromobility, sustainability, industrial engineering, and so on. Just check out the website. It's a great read. Okay, so let's start with the monitoring topic. Today, so we see a paradigm shift from single effects towards a multi-level monitoring concept. So you see this here on the left. You normally observe on a high level from satellite, using satellite imagery, or from planes, airborne photogrammetry, of a large area to spot certain effects you are interested in. And then you go further and further into detail, looking at the effects, conducting distinct measurements, and placing sensors on the site towards really online measurements. So sensors have internet connection, and you can really avoid capability monitoring. And these are all topics which comprises to the name the data management, visualization of the information, and the analysis. At DMT, we operate a so-called platform, which is basically a database which is located at premises, which is able to handle all kinds of sensor information on the site, yeah, like GPS positioning, like inclination measurements, level gauges, groundwater level gauges, weather information, and so on, can all import to our database. We have it there available for an analysis, and we can also share it with our project engineers or our customers via web front end. So we can plot all information web browser on mobile devices, and we also have then the capability to analyze the data, of course, inform the client if something an effect is observed, and we can send out alarm messages. And this is how it looks like, yeah. If you log into site Safeguard, you see on the left your project. Here, this is a construction of a bridge, and you see a map here of the construction which are in place here. In this case, level gauges which measure the water level on the river and on the channel, groundwater level measurement devices, and also devices which measure displacement and observe deformation of the construction site. This is available, it's interactive. I will show you on the last slide of the presentation an interactive presentation or an example of this. And we can also integrate map data, so which is used for planning of projects. Yeah, for example, you can draw here your access paths, your roads, your forbidden areas, or your storage areas for certain project. And this enables the project team on site, yeah, to have all information on the tablet, on an iPhone, and all information available on site. We can also integrate huge data sets which come from satellites, for example. This is an example here from remote sensing, satellite remote sensing. We can receive results of ground deformation, for example, which are huge point clouds containing of several 100,000 of points. We can integrate it here in a map visualization and basically show this to the client. The client can analyze interactively and use this information. And we can also create dashboards, yeah, really flexible. We use a tool which is called Grafana, which is directly implemented in our platform. And we can create custom presentations, pie charts, normal line charts, statistics, everything what is specifically needed for a project, for an analysis. We can basically set it up here on the web front end. And of course, everything is available on mobile devices. So we have an iOS and an Android app, which is basically mirroring the web front end, giving the project personnel on site all the information. So you can go on site, have your mobile phone, you see there are the sensors placed, whereas the current situation. You can also use your iPhone to take observations, yeah, making a picture, sending it directly to the database as an additional information for the project. So key functions, yeah, connectivity. So we can basically connect all sensors to this platform. Some sensors can also be controlled via our platform. We have maps and geolocation, which is very important. Geoinformation systems can be connected. We have data visualization. We can report and create tables automatically. So if your client wants to have, for example, every day 6 a.m. wants the latest report on the monitoring project, the system automatically creates a PDF document and sends it to the client automatically. We have an analytics and alerting function. Yeah, you can create threshold values of deformations. For example, if a slope moves in a critical way, automatic alert is sent out, and also we can manage documents for the project, which are important, and the platform allows basically to share documents, photos, inspection records, and so on within the project team. Fields of application, manifold. Yeah, you can imagine you have, of course, the application in mining. We go on with this. You can, in subsidence monitoring, stability, deformation of slopes. Yeah, you have tunneling. You can check or manage your monitoring of the tunnel ventilation or of blasting, tunnel driving. Infrastructure, of course, excavation pit. You can monitor the stability of an excavation pit. Bridges, really large topic worldwide. Stability monitoring of bridges. You can use it for natural hazards, like slope stability or earthquake seismicity, and also in the industrial environment for plant surveillance, refineries, power plants, and so on. And we offer this in basically a variety of applications. We have a one-stop service where basically DMT is consulting the client on every aspect. On the sensors necessary, we support with the sensor installation, with the maintenance, and we use the platform for the data management. Or we can just use the platform, provide this to our client, and the client has its own sensor suite on site, his own information, and only uses Safeguard as a platform, as a service, how it is called. Okay, so based on this, on our platform which is available, I want to talk about slopes and general monitoring of slopes. Slopes, a huge topic in this area are tailings. We have around 20 or 18,000 tailings worldwide, which are largely abandoned or not operative. But a really large number of different tailings, different types, embankments piled up, dry deposits or tailing dams, which represent a huge, not problem is the wrong word, but a risk is involved, if not properly maintained. And we had some catastrophic event failures in the past, like here in South America, disasters in Brazil and other areas, tailing collapse with casualties and huge environmental impact. And we have studied this in the past. If we look back, there are databases regarding tailing failures, and we see, looking back 100 years, that the number of severe accidents is increasing over time. And with really strongly increasing impact on the environment, on the social and monetary risks involved. And you can actually also calculate a monetary risk for a tailing failure for a company, which is calculated here with around 450 million euros, a huge amount of money, which a mining company has to basically save in advance in case a tailing failure occurs. And this is such an amount of money. You could think it would be better to invest a kind of money in monitoring of tailings and early prediction and early warning of failures to mitigate the risk. And this is exactly what we have done in the past years. We developed a tailing monitoring system together with other companies, research institutions. And the system comprises of various technologies to improve the monitoring capabilities and reduce risk. We have the component of geotechnical monitoring. So this is mainly sensor networks which are installed at the tailing site and operated. We have radar remote sensing, so using satellite data from space to measure ground deformations, tailing instabilities. We have optical remote sensing, focusing on leakage detection. So if some liquids outflows are around the tailing which are harmful for the stability, We have, of course, modeling, so stability modeling and also geohydraulic modeling. And then the important thing is data integration. So to get every aspect, every information inside a common database and make it available so that they can jointly be interpreted and analyzed. Okay, what do we have for technologies to observe slope stability? These are some important ones. We have GPS or GNSS, point-wise measurement, a sensor which can be placed on a slope, measure deformation. We have total station monitoring. I will show these technologies in a few minutes. Observing certain target points on the slope. We have ground-based radar, which is an aerial measurement technology, and we have terrestrial laser scanning. And yeah, the presentation will end with terrestrial laser scanning as we have a new system developed. So if we start with GPS, there are several GPS systems available on the market. We have our own at DMT. It's a low-cost system, so which has a really low price point and allows to install a lot of these antennas and receivers on a tailing site, for example. They are can be operated with solar panels, so you need no external power supply. They have a built-in modem and data transmission. And the information of these systems is automatically sent to our safeguard servers. It's processed, and the result is a three-dimensional movement coordinate every 24 hours. So every day you have a information on the stability of your object, your tailing or slope. They have a quite high accuracy, below 5 millimeters. So this allows to detect already small movements of an object. This is how it looks here in this box. We have a solar panel. This is the antenna on the right side. And here's an implementation example from Chile, South America. You see here the tailing. It's an Anglo-American tailing, and you see on the top we have an installation of these sensors. They are processed together with outside stations, so which are far away, which can be considered as stable. And so we are able to process the deformation and stability over time. This is the installation on site, and basically you see on the web platform the locations of these devices, and you have the possibility then to look at the data. In an ideal case, this is always stable. Yeah, there's no movement. You see here the system's east, north, and height component, and you can observe the movement or the stability. This can be combined. This is another case here, an open pit mine in Germany. You see here these orange points. These are the GPS receivers, and they are combined. You see it here on this image, with a so-called corner reflector. And we use it for combining GPS with the next technology, which is radar remote sensing from space. So you can actually use data from certain satellite systems, make a processing and derive highly accurately the ground deformation in an aerial way, not a pointwise way, which is GPS. Rather, you get an large area map of the deformations. And this is possible by using satellite data. We have free of charge actually data available from a satellite which is called Sentinel-1, operated by the European Union. And we have commercial data, which is a little bit higher quality, but costs money, which is called TerraX as an example. And this offers to process ground deformations every 6 days, every 10 days, depending on the satellite, with a high accuracy. Yeah, we are in theory in a millimetric level of accuracy. And you can see here in the image below, you can early detect some unstable areas here in the middle of this tailing, which helps basically to take countermeasurements. So inside the platform, inside Safeguard, we can import this data in real time. And you see here all the points which are derived from the satellite analysis. And you see stable points here in dark green. And you see some areas here in the middle of the tailing show. And you see here the small settlement also in this chart representation. And this can help to early detect certain phenomena which can lead to instabilities. So another technology is total station monitoring, which is widely applied in the industrial in infrastructural area. This is an instrument that's shown here on the picture below. You see it here, target prisms on the slope, for example. So you need to go on site, you install the targets, and the total station basically measures the deformation over time. So we can really measure every 20 minutes, every 10 minutes, each target point, and you will get a quite highly accurate result, so around 5 millimeters accuracy every 10 minutes. And this can also, of course, be then analyzed. You can show stability, or you can detect movements over time. This is widely used in the mining environment. Yeah, we have here an open pit mine in Germany. They have the equipment here in this large housing, solar panels on top for the power supply. And this is located here on the right, to observe this high wall of a large open pit mine in Germany. They have a lot of target points on this high wall, and they basically use this instrumentation to observe the stability and early detect movements. Okay, so now a little bit focused here, LiDAR monitoring for slope stability observation. What is the main advantage? If we look at classical methods like total station, as I have shown, you can measure here some discrete points on a rock slope, just as a representation, in this case, points of interest. Not an aerial measurement, it's point-wise. Yeah, and you need, of course, to plan the locations of these points to be in areas there you expect movements, or there you want to check stability. So you need some information from the beginning on the movement behavior. It's a quite costly installation. You need to access the slope. Yeah, you need to place there your targets, which is also often not possible because it's a safety risk. And you measure only point-wise. So if you have a movement in an area where no target prism is installed, you will, basically don't see it. However, this is widely applied. It's a really sophisticated measurement method. And we have here an example from Chile, Codelco, Chuquicamata, which is the largest open pit mine in the world. And you see here an installation we have in our system, containing of 10 total stations. And you see here SH9, it's a total station point. And you see a lot of target prisms on each side of this slope to basically measure every movement and cover the whole area. But it's highly time consuming and costly. Yeah, but it's possible. So now we shift to laser scanning. Laser scanning is something totally different. You don't measure point-wise. You measure you cover a whole area of interest with a point cloud. Yeah, because so you don't need to place here any targets. You don't need to access the risky and safety related areas, and also you can measure every 10 minutes. So it's a almost real time monitoring, and you don't need to have reflectors or target points at the site. This is probably known as a campaign wise measurement technology. You have some examples here. You can scan a whole industry plant inside, which is here in this case a steel plant in the middle of the screen. You can do this campaign wise, and then you can basically compare 2 or 3 campaigns measurement times and detect deformations. That's the main purpose. Or you can here scan whole mining shaft buildings, or you can also place it on a drone, on an aircraft, and scan from basically from the top mining areas here, an open pit mine, and you can also detect then by comparing different measurement campaigns. You can detect changes in the surface geometry. Yeah. The thing is now we want to have this available as a real-time permanent monitoring system. So what we did, we have a cooperation with a company which is called Riegel. Riegel is a manufacturer of long-range laser scanning. It's quite known in the mining industry. And we have developed a connection, a telemetry box to be able to access the scanner and also download the scanner data from which the scanner recorded. And this is connected again via a secure internet connection to our data centers in Germany. And then it goes directly into Safeguard. And then you have all the capabilities which the monitoring platform offers. So mapping, you can analyze the data, you can create alarms, reports, and so on. Yeah, and this is the scanner, and we had to develop an application, an app on the scanner, which basically allows us to access and export data. And what you can do now, you can place your scanner. This is a picture from a trade fair last year. We have been really active to promote the system together with Riegel. You place the scanner anywhere. You connect the scanner to the internet, and then you have the Safeguard platform, web front end, and you immediately see the scanner information here on the screen, and you see all the information, different points measured on the screen in real time. So from the data center, the current service is a real-time automated service. So you place the scanner, I will show it in a minute. You then get on the web platform a visualization, a web view on the measurement object. You can see the deformations and the stability. And you can also conduct, this is real time, and then you can conduct so-called post-processing. So you take all your measurement information, your different campaign scenes, and you can basically conduct a deep analysis of deformation and conduct even geological mapping and so on. I will skip this. I will directly show the application example here. This is in a region in the Austrian Alps, so a mountainous region where you have landslides as an effect. And of course, this is a risky area here with a landslide already fallen. And we have an installation which is shown here. You see the small hut measurement booth here on the right side where our scanner is placed. And the scanner basically measures now the whole slope here, the whole area, unstable and stable on the other side of this valley. And I will just change here my screen. I can go live here in our system. You can now see basically the Safeguard web interface real time. You see here as a first function the map of the area. Here's the slope I have shown, or you have seen on the picture. And you can dynamically zoom in, and you see here is our scanner location. And we have also a weather station here, which gives information on the temperature, humidity, and rainfall, and so on, which might be very interesting. And you can go here to scanner. And what you see is now the current situation on this slope. It's a graphical visualization of the point cloud, which shows the deformation. So from the starting epoch until today. And you can color code this representation, and you see basically the whole slope now in 3D. And you immediately see the stable areas, which are gray. And you see moving areas, which are colored. And the movements in this case are the trees and the vegetation. Trees are growing, so we detect their movements. and their deformation. And we have also here some agriculture areas, some crops which are here planted, which are growing, and we are able to detect it. And important is we are also detect here the whole slope area. It's basically stable. There's no movement. We have some erosion due to rainfall, some areas which show some erosion effects here on the slope. And this gives an aerial overview on the slope. And you have also a dashboard where you can see additional information on the scanner. If the scanner is basically stable, you see here the information from the weather station. So wind direction, rainfall, which can be a really nice information regarding slope stability. And you see here also a time series of all the reference point on the slope over time. So measurement points 1, east, north, and height information for all points. Is an open access demonstration page. All right, so I have already shown this. We have applied the system in South America with our customer Anglo-American. You can see here a tailing which is abandoned, and the scanner is placed here on the other side, is installed and measures the geometry of this tailing. And you can see on the platform here the geometry, and you can see all the status parameters of the scanner inside that. Also a highway building project in Germany. They're constructing a highway bridge, and they're interested in the slope stability of this slope here near the pillar. And we also did there the installation, and it's really helpful for the geologists, for the geotechnical engineers, not only to have a point-wise information, but to have the aerial view, the aerial information regarding slope stability. In red, of course, is the equipment here, the construction equipment, cars and so, which are also detected as changes. But on the slope, there's general stability. This is the address of the website I just showed. You can access, and what's great there, you can download by our partner Riegel. It's about 20 really in depth what all about, how to apply recommendation installations and your impression on the use and application of the system paper from this website. That's already it. For your attention. And contact me anytime. Question for your disposal to answer your questions. Thank you very much.
All right, thank you very much, Karsten. You can raise your hand just and ask. I'll start with myself, Karsten. With regards to this, on the you showed one of the images there, the slope, right, and then there's obviously changes and movements in vegetation. To see the actual slope ability or slope movement when there's vegetation moving, or can you be able to detect the difference between maybe vegetation and the actual slope, and how?
Yeah, that's absolutely right. This is still a problem, or would be a problem if we have a slope with vegetation on site. We are currently having this is still research and development to apply filters and to apply also artificial intelligent filtering to filter these noise basically due to it of the result. And we currently have started a research and development project with 2 universities in Germany to exactly improve and tackle this problem. our experience in a lot of mining cases, of course, the slope is there's no vegetation on the slope, so this is a minor problem. But for natural hazards like slope stability in alpine regions, also a limitation at the moment.
Any more questions, anybody? I'll take that as no questions. We've recorded this presentation. I have a presentation shared with everybody else. Recording will be shared to everybody else. Karsten, thank you very much time to present to us. And thank you a lot.
Yeah, thank you very much. Bye-bye.
Thanks everybody who joined. Bye-bye.
Okay, so their hands are open. Thank you, Tom. Bye.
Sure, thanks.
Thank you. Bye. Good night.